All right, team, here are our 5-4 notes. We're going to talk about proving properties of parallelograms. So in 5-3, sorry, actually it was in 5-2, we talked about the properties of a parallelogram. So 5 properties of a parallelogram, you guys, we're going to restate them here because then we're going to look at how we can use those properties to prove that a given quadrilateral is a parallelogram. So we have first the properties of a parallelogram. If a quadrilateral is a parallelogram, then we know these 5 things about it. So first we know that both pairs of opposite sides are parallel. And that's probably our most defining characteristic of a parallelogram, hence the name. Okay, but we have both pairs of opposite sides are parallel. We have both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Consecutive angles are supplementary. Consecutive, you guys, means next to, as opposed to opposite, right? Consecutive angles are supplementary. And the 5th property of diagonals bisecting each other. Whoop. Diagonals bisect each other. Oh my gosh. Here we go. Okay, now someone asked me the other day, how do you remember all this? Okay, honestly, you guys, I reference my notes all the time. I have notes from last year that I look at to make sure that I complete these notes correctly. So all that to say, you guys, make sure you have your notes out, right? We're taking these for a reason, and it is going to be really challenging, next to impossible, to remember all of these different properties, especially right off the bat. So you got to keep engaging in them, and you got to keep referencing your notes, right? Usually by the end of the unit, I can remember them a lot better, okay? But I have my notes out as much as I need to until I don't need to use them anymore. So obviously the goal would be to wean off the notes at some point, but while you're learning, while we're doing these problems for the first time, make sure that you have your notes out, and make sure, you guys, that you are writing them down while you're watching the video, okay? So both pairs of opposite sides are parallel. So what I'm going to do is, just for visual sake here, we're going to draw a parallelogram and we're going to mark all those 5 properties as best we can. So when we have a parallelogram, if we know it's a parallelogram, then we know. So actually what I'm going to do here is I'm going to write the inferences that we can make when we know it's a parallelogram. So if we know it's a parallelogram, then we know that both pairs of opposite sides are parallel and congruent. So the parallel piece is the arrows, and the congruence is the tick marks. We know that both pairs of opposite angles are congruent. I'm going to go ahead and name this A, B, C, D, because then we know that A plus B is 180, A plus D is 180, B plus C, and D plus C. So each of our combinations of angles that are right next to each other would be supplementary. And then finally, we know that diagonals bisect each other. So they don't necessarily bisect the angles. That's only in rhombuses. But they do bisect each other. Okay, so I'm going to add those tick marks in. Okay, so there's a lot of stuff going on that picture, but all we did was we identified the 5 properties that we know if the quadrilateral is a parallelogram. Now, the converse idea, and we talked about converse a little bit in our last unit, is when we switch the order of what we know and what we can conclude. So in these ones, we know it's a parallelogram, so we know it has these properties. If we want to prove that a property is that a quadrilateral is a parallelogram, then there's a couple of these properties that we can use to prove it. Okay, now we can't actually use all of them. There's a couple that don't quite work just exactly the same, but there are several that are going to be very similar. So if a quadrilateral has both pairs of opposite parallel sides, let's go here, both pairs of opposite sides parallel. So if that is a property that we know a quadrilateral has, then the quadrilateral is a parallelogram. If a quadrilateral has both pairs of opposite sides congruent, then we know the quadrilateral is a parallelogram. So looking pretty similar so far to our properties, okay, but we do want to make sure that we recognize that these 5 that we're listing now in this section is if we want to prove that a quadrilateral, and we've been doing proofs all semester, right? If we want to prove that a quadrilateral is a parallelogram, then we're going to need to prove one of these 5 properties. So we have both pairs of opposite sides parallel, both pairs of opposite sides congruent. If we have a quadrilateral that has both pairs of opposite angles congruent, then we can confidently say it's a parallelogram. Now this is where it gets different, okay? It switches up from our properties up above. If we have a quadrilateral whose diagonals bisect each other, then we can state it is a parallelogram. And the last one is if we have a quadrilateral that has one pair of opposite sides that is congruent, one pair of opposite sides, congruent and parallel. Then we can state that it is a parallelogram. So we'll recognize, you guys, that the 4th property of a parallelogram, that consecutive angles are supplementary, is not one of the properties that we can use to prove that parallelograms are, or prove that quadrilaterals are parallelograms. Okay, so again, if we want to prove that a quadrilateral is a parallelogram, then we need to use one of these 5 that are in our second section here. And they are related to our properties, but are not exactly the same. So, can you prove that the quadrilateral is a parallelogram based on the given information? If yes, state the reason. So if we say yes, then we have to pick one of those 5 reasons that we just listed in blue there, okay? So, first one here, we have 2 pairs of opposite congruent sides. So, yes, we can prove that this is a parallelogram because that matches up with our second reason there. So I'm going to actually go ahead and just put number 2 from this list. Okay, so let's identify that these are reasons we can use to prove quadrilaterals are parallelograms. So in the same way that we had, what happened to my writing? Okay, write it. Reasons to prove quads are parallelograms. In the same way that we had certain reasons that we could use to prove that triangles are congruent, right? Side, 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 angle, etc. We had a certain set of reasons that we could use to prove triangles are congruent. These are the reasons that we can use to prove that quadrilaterals are parallelograms. So yes, this one works. It is number 2 from our options of our reasons. Okay, second one here, we have one pair of opposite congruent angles. That is not one of our options, so we do not have enough information here. Not enough information. On our third one, we have a pair of opposite sides that are congruent. We have our tick marks here that mean they are congruent, and they are parallel. So this one does work. This is reason number 5 from our list of reasons that we can use. One pair of opposite sides that are congruent and parallel. Now, for these examples, you guys, I'm just writing number 2 or number 5 or whatever because we know what I'm referencing. In practice on a problem in the proof we're going to do, you can't just write number 2, number 5, right? There's no context there. So you will write out the property. Okay, next one is we have diagonals going through our shape. And these diagonals do, in fact, bisect each other, which is the 4th reason that we can use to prove that a quadrilateral is a parallelogram. So that is one that we can use. Next one is we have both pairs of opposite angles congruent, which is our 3rd reason that we can use to prove that a quadrilateral is a parallelogram. And our last one here is we have 2 pairs of opposite parallel sides, which is our 1st reason. So yes, we have enough information. We can use the 1st reason there to prove that this is a parallelogram. So now we're going to put those properties in practice. So we're going to write a proof here. Given parallelogram ABCD with AC congruent to BD. So this is actually, it's given to us that this is a parallelogram. So that means that the properties of a parallelogram are true. So on this one, we're not trying to prove that this is a parallelogram. We are trying to prove that triangle ADC is congruent to triangle BCD. So let me acknowledge too that these are also reasons that we can use in proofs. Just not proofs to prove quadrilaterals are parallelograms, but just proofs in general. So these would be reasons that we would use if we already know that something is a parallelogram. So for example, in this problem, we know that ABCD is a parallelogram, so we know that all of those properties that we listed first are true. So game planning here, we want to prove that triangles are congruent. That means that we are going to end with one of our 5 options, or angle, side. Okay, those are our options. We know we're going to end with one of those, which means that we need to prove three pieces of congruency, or 3 statements about our triangles. Okay, so let's get a statements list going here, and reasons. And then we are always going to start with our given. Okay, so 1 given, and I'm going to write out all of the information that is given to me in that statement, you guys. So I'm going to put ABCD is a parallelogram, and AC is congruent to BD. Okay, so that is our first piece of congruency. We have a side of our triangles, and I'm going to go ahead and actually redraw my triangles too. Good idea, because they are overlapping, so I want to make sure that I can mark what I need to mark and see my triangles correctly here. So I have BCD, ADC, those are the two triangles I'm trying to prove are congruent. And then I already stated a piece of congruency in my proof, so I'm going to mark it on my picture. AC is congruent to BD. Okay, now a couple different ways we can go here. There's actually a lot of different ways we can go here because we could state that this is a rectangle, but we're going to go ahead and just work off of our sides. So I'm going to aim for side, side, side here because I know that a parallelogram has opposite congruent sides. So AD would be congruent to BC because it's a parallelogram. So I'm going to mark that in my, or I'm going to mark it on my picture here, BC congruent to AD. And I'm going to state it in my proof. AD is congruent to BC because opposite sides of a parallelogram are congruent. Okay, and then my third side I know is congruent on my figures because they shared it. So they both had CD, and then we pulled them apart just to separate them, but because they shared CD, I know, oh, and here's another side, right? And because they shared CD, I know that CD would be congruent to DC itself because of the reflexive property. Again, whenever they share a side or angle, then it is the reflexive property. Okay, so now I have my three sides marked congruent. I have enough information to state that triangle ADC is congruent to triangle BCD by side, side, side. And we are done with our proof. We did what we were supposed to do, so QED. All right, so again, a couple different ways you could go with that proof there. If you see a different way to do it, go ahead and let me know in class. Or send me a reminder. I'd love to hear your ideas for how else we could go about doing this proof. But this is probably the shortest way, so we're going to look at this way for now. All right, and that is it for our notes, you guys. Let me know if you have any questions.